doing today? Section 7 is all about determining whether or not a distribution is normal. So before we did all the normal calculations, and I've told you you're only allowed to use the normal term when I tell you that a distribution is normal. Today we're going to talk about what are the ways that we actually test for normality. Okay, the way that you test for normality is using a normal quantile plot, which is written at the top. Write that down. Normal quantile plot. They are also called normal probability plots. They mean the same thing. So a normal probability plot or a normal quantile plot, those are the same. Okay, so this first graph is a dot plot. The distribution looks fairly bell-shaped or symmetric. It may be normal. The bottom graph is a normal quantile plot. So what a normal quantile plot does is it plots x versus the z-score. So a normal quantile plot is x versus the z-score for that x value. If the distribution is normal, the normal quantile plot will be a straight line, or very, very close to a straight line. You just have to use your best judgment. Does the line look straight? Does the data look straight? Yes, it does. Therefore, we believe that the distribution is normal. These would be normal quantile plots where the distribution is not normal. So on the left, we are skewed right. So the tail is over here to the right. And as you can see, we curve off. The distribution on the right is skewed left. I'm not going to have you look at a normal quantile plot and tell me what the shape is. All I'm going to have you do is look at this normal quantile plot and say, does the distribution look normal? And you're going to say no, because the data is not linear. That's pretty much the whole section. You good? Okay. Here are some other ones that are mentioned in the book. So skewed is going to look like A, B has heavy tails, and C has an outlier. C, that should make sense. It's all straight except for one point out there. So that means that we have an outlier. Okay, the other thing that we use in order to determine normality besides a normal quantile plot is the R value. So generally what happens is you'll construct a normal quantile plot, and then you'll find the R value that correlates to that graph. So in this case, the R value is 0.998. The hardest part about this is that there's no set rules for the R value. So before, when we calculated the correlation coefficient, I told you if R was between 0.8 and 1, it was a strong distribution or a strong correlation. That's not the case now. Instead, what happens is you compare your R value to what's called the critical R value. And so it's something that you look up in a table. The critical R value is based on your sample size. So you would be given a table on any question where you needed to use it. And then the table will give you 5 critical R values when the sample size is 10, 20, 30, and 40. And then what you do is you compare your R value to that critical R value. If your R value is smaller than the critical R value, that suggests non-normality. So you want your R value to be greater than the critical R value. So again, you're going to compare your R value to the critical R value. Your R value should be greater. If it is, that suggests normality. If your R value is less than the critical R value, you're going to question normality. You're not going to say for sure that the distribution is not normal, but you're going to question it. Here, I don't know what the sample size is for this distribution, but let's say that it's 35. The table's probably not going to give you 35. It's going to give you 30, and it's going to give you 40. What you want to do is you want to round up. That'll be stricter, so it'll be a higher critical R value. So when you're between, you always round up so that it's a higher R value. So then here in this case, this is 2 more distributions that are not normal. There are the R values. So in this case, the critical R value might be 0.96. In this case, both R values are less than 0.96, so we question normality. It gives us reason to believe that the distributions are not normal. Okay, questions? Last thing that you need to be able to do. This is not in your homework tonight, but it is going to come up again. Is you're going to have to be able to construct a normal probability plot. Your calculator does that for you. So I'm going to show you right now how to do it on the calculator. So go to Stat, Edit. Let's edit our first list. Give me a distribution that's probably normal. On anything that's normal.
Height.
Height is probably normal. Okay, so let's just take a few data points. I'm going to ask the first row, or the first column, can you guys give me your heights in inches? Nazim, how tall are you in inches?
72.
Okay. Ben, how tall are you in inches?
71.
Greta?
69.
Leah?
71.
Okay, of course you're going to have a much bigger distribution than this, but let's just start with that. Okay, so go to second, stat plot. You want to turn the plot on, your first plot, which yours probably is on already. Okay, the normal probability plot is the last one. That's a normal probability plot. And then do zoom 9. Is that what yours looks like? That's a normal probability plot.
No.
Yours does not look like that?
Okay.
Okay, you did something wrong then.
It looks kind of like that, but not. I don't know.
Okay.
I can't choose.
Cool.
What do we
Keep
put
going
on
like
steel?
this.
It looks like that.
Nothing.
Oh, nothing. Okay.
No.
And then what do you prefer?
Okay. Anytime that I asked you to construct a normal probability plot, I never want you to do it by hand. Do it on the calculator, draw me a sketch. If I ask you, is this distribution normal, and you decide to construct a normal probability plot, do it on the calculator, don't do it by hand. Any questions? Comments?
Yeah.
Okay, so your